Welcome to a new video.
First of all, as always, welcome to this small YouTube channel dedicated to cloud topics with Azure, development focused on .NET and the world of data, with a special interest in Databricks. I'm Antonio, a software architect with many years of experience, but as I've always said, what really matters isn't the years, but your current knowledge and the level that you have reached. Subscribe to the channel to stay tuned.
Automate your pipelines with Databricks Asset Bundles. Chapter 1. Basic concepts of Git Folders, Databricks CLI and Service Principles. What are Databricks Asset Bundles and why should you start using them?
This is the first of two chapters in a mini-series about Databricks Asset Bundles. In this first video, I'm covering the basics of Databricks Asset Bundles, as well as Git repos, Git folders, service principles for automation, and the Databricks command line interface tool. These are essential components for efficiently automating your pipelines and for properly understanding how Databricks Asset Bundles work. In the second video, I'll be showcasing a demo with a very simple but insightful project to be deployed from the scratch.
Databricks Asset Bundles are packages that group all the resources of a Databricks project, such as notebooks, jobs, configurations, and dependencies, into a single set or bundle. They are used for easily organize, version, and deploy Databricks projects. This applies to both development and production environments. The image on the right shows an example of a project configured for deployment with Databricks Asset Bundles. It includes a configuration file, databricks.yml, with the bundle name, resources to deploy, jobs, dashboards, source code with notebooks and payson files, variable definitions, use of automation service principles, and territories or environments, development and demo in this case. We'll look at this in detail later. For now, in this first video, we'll explain basic concepts of Git, service principles, and the Databricks CLI to help you understand it better. This is the simplified workflow a developer would follow to deploy a set of assets using Databricks Asset Bundles in a development environment, although it would also be valid for any other environment. However, for QA, staging, or production environments, the use of CI/CD pipelines is recommended for fully automated deployment. In any case, pay attention to the entities involved in this workflow, particularly the Databricks CLI, service principles, and Git repositories. We will explain what each of these entities is and then return to this diagram for a more detailed description. We will also explain how a deployment from a CI/CD pipeline works, highlighting the key differences and points. Components you should use if you want to automate professionally. Databricks Git folders are folders within Databricks that are connected to a Git repository, for example, GitJab, GitLab, Azure DevOps, or Bitbucket. They allow working with the repository code directly in Databricks. This allows you to edit notebooks, commit changes, and synchronize changes without leaving the environment. For efficient automation, using Git repositories is essential, as it enables you to clone and deploy the appropriate branch with all the source code. While not strictly required, using Git folders is highly recommended, as it allows developers to work directly within the Databricks environment on Git branches, significantly simplifying the development and debugging process. Without Git folders, all code must be managed and executed from an external environment, such as Visual Studio Code, which can be more resource-intensive.
There are two main types of identities. The first one would be those associated to people, human beings, and the second one would be those associated to applications and services. If you want to automate your pipelines, you should be using service principles, that is, identities associated to services, instead of using identities related to users or human beings.
A service principle is a non-human identity used to automate tasks in Databricks. It allows authenticate without using personal credentials. In these videos, we'll cover script executions, pipelines, and interactions between external tools and Databricks. We'll register a principal service in Azure and link it to a principal service in Databricks. Then, we'll use this principal service, with authentication via its associated secret, to execute deployments with Databricks Asset Bundles from the Databricks CLI. We'll also configure our pipelines or jobs to run not in the context of a human user, but rather in the context of this principal service, which is much more efficient in terms of automation. Here's how the registration of the same primary service appears in Azure and Databricks. Notice how the application ID, that is, the client identifier or primary service identifier, is the same in both cases. That's all for now, we'll look at it in detail later. Databricks CLI. It is a tool that allows you to interact with Databricks from the terminal or command line. It is used for manage and automate tasks in Databricks without using the web interface. Look at the image on the right, which shows how to install Databricks CLI in a Windows environment in the simplest way. It's as simple as running the wingit install command with a reference to the Databricks CLI package. Once installed, the path variable is updated, so you can use Databricks CLI from any location on your machine. Look at these examples of command execution using the CLI to obtain the version, clusters, or jobs defined in a Databricks workspace. The accessed workspace, along with the authentication information for the service principal, is configured in the default path and file shown on the right of the image. The name of the Databricks profile appears in brackets. This profile must include the host, tenant, client identifier or service principal, and associated secret. This profile is referenced in the CLI commands using the global parameter p for profile. Finally, note the commands to execute the validation, bundle validate, and deployment, bundle deploy, of the asset bundle to the Databricks environment defined in the t parameter for target or environment. In this example, the Git branch to be deployed is the current branch of my local environment. We will later explain how to configure the asset bundle to include variables, resources, and environments in the deployment. Having explained what Databricks CLI, service principals, and Git folders are, we can look at the following diagram in more detail. Manual deployment with Databricks Asset Bundles. The developer clones a branch from the Git repository and optionally makes changes to it. The branch must contain a databricks.yml file with the asset bundle configuration, variables, resources, etc. Databricks CLI must be installed and configured before proceeding with the deployment. The developer executes the deployment with the command Databricks bundle deploy from the CLI, referencing as parameters the target or environment in which to deploy and the profile containing the authentication information with service principals. If the authentication is successful, the bundle is deployed. Optionally, manual or automated tests and possible error corrections are executed. The validated changes are saved to the branch, and the deployment is restarted until everything is verified to be correct. CI/CD deployment with Databricks Asset Bundles. If the deployment is performed from an Azure DevOps, GitHub, or other pipeline, the process is similar but with some key differences. First, the pipeline can run manually or automatically, after detecting changes in branches configured for this purpose, such as the main branch. Once launched, the Databricks CLI is installed and configured. Next, the pipeline authenticates with the repository to clone the source code. Depending on where the pipeline is running and where the repository is located, this process may differ. The pipeline must obtain a token to download the branch to be deployed. After this step, the process is the same as described above. Optionally, it is possible to validate the asset bundle with the bundle validate command before proceeding with the actual deployment using bundle deploy. Also, after deployment, it is possible to run setup and error handling tasks. Finally, log results and trigger notifications. In the following video about Databricks Asset Bundles, we'll see a practical demonstration of how to perform a simple manual deployment using the Databricks CLI automation service principles and a Git repository on GitHub. If you found this interesting or want to stay updated on new content from this channel, please like or subscribe by clicking the bell icon.